All right, yesterday we completed like 3 problems is all, and it took like forever. Some of these problems take longer than others. Do not get discouraged. Put down all of the information that you need. Sometimes it will be nice to factor it, like we did for like the first one, or like substitute things in. Sometimes you will need to get an answer by using the calculator or the computer or whatever to do that for you. That is what we did for this second one right here. Okay, so review back to this guy. We got an answer as soon as we substituted in. We got s squared plus 120,000 over s minus 6,000 equals 0. Yeah. I don't know how to factor that thing down. It's not even quadratic. I can't factor him. I can't use the quadratic formula. I can't do anything. Why? Because he is disgusting and he is a cubic function. And I don't know what to do with cubic functions. So I type that big long thing into my calculator and I have it graph it for me. Okay? And what we found when you graph it, as long as you graphed it correctly, we had to zoom very carefully on different places, and we got 2 solutions, 21.7 and 64.29. Those were the 2 things, 2 possibilities of what our base could look like. Yes? Yes. Yes? Okay. Yes. So sometimes you'll have to graph. Sometimes it's nice to just factor it down or use the quadratic, but you can't do that when you have a cubic function. Yes? And this wasn't even cubic. This was like a cubic plus a rational function because we had s in the bottom. So that's all sorts of messy stuff. Just graph it, okay? You might have to zoom weird places. That's fine. Zoom out. If you can't see your function, then zoom back in, all right? There are some strategies for you. Okay, now, the back side of this is going to start talking about interest, okay? When you're calculating interest, there are 3 things that need to be taken into consideration, right? If you put money into a bank account, how much interest is it going to collect? Well, it depends on how long it's in there, which is time, right? How much you put in to start with, and then what else determines that? Time, how long it's in there, how much I put in, and the rate of interest, which is R, right? Okay? Nowadays, in banks, like if you put your money into the bank, you might earn like 0.3% interest, okay? So if you put like $5,000 in a bank account, you might get like 4 cents every quarter, right? Which is like, but if you put your money into like a CD, like a certificate of deposit, or invest it in something, you're going to get a lot higher dividends or a lot higher interest rate off of that, yeah? So really the worst thing to do is just have your money sitting in like a bank. Okay, you want to put it in savings. You're right. The worst thing to do is spend all your money. But the worst thing, if you're going to have a bunch of money sitting around, don't just have it sitting in your banking account. At least transfer it to savings where there's a higher interest rate, or invest it in something, right? Yes, you are right. The worst case scenario is spending all your money. But if you're having money sitting around, don't put it in the bank because it has really bad interest, okay? So here is your equation for interest. The interest that you accrue is based upon your P is principal. Principal, pal. What is a principal? Sure. What is a principal?
It's the starting amount.
The starting amount. Start monies. Starting dollars, okay? The R is the rate, okay, as a decimal. I'm going to put DEC, rate for decimal. And then time, okay? Now, your time depends on how your equation's set up. So maybe if your interest rate is set up to do per month and you have a whole year, you're going to want to substitute 12 in for R, right? Okay? But if you have your interest rate set up to be yearly, you're going to want to substitute 1 in for T. So we'll talk about that later, but we'll get to that point, okay? So interest equals principal rate times time. We're going to use that to do the first problem in the back. Ready? And go. Example 4 on the top of the back. Can I make this bigger until we start doing actual calculator stuff? Can we do that? Sure. Okay, so stock and savings returns. We're going to do a couple different things. It's not just going to be one simple interest equals principal rate time. But I am going to write that at the top. Interest equals principal rate time. PRT. Okay? All right, so I'm going to put some of my work up above here because I gave you not very much room. Sorry. All right, so help me think here because I don't necessarily know what I'm doing here yet. A high-risk stock pays dividends at a rate of 12% per year. What's a high-risk stock?
There's a risk that it can decrease.
You're all in or you're all out. There's a really good risk that it's gonna like maybe go bankrupt. So that's why the interest rate is so high, because maybe I get lucky and I get all 12% interest back plus my amount that I put in and I'm making bank. But there is a chance that I could lose everything and not get nothing back, right? So they make that interest rate reflective upon whether it's a secure investment or not. You're going to have really, really high interest rates with investments that aren't very secure because they want you to invest, but there's a really good chance that they could give you nothing back, right? So 12% per year, and a savings account pays a 6% interest per year. How much of a $90,000 investment should be put in the stock, and how much should be put in savings to obtain like an average, basically, of an 8% per year on total investment? If we average it out, I want 8%, right? So we've got kind of like three things going on here, okay? Let's talk about our two different types of investment first, all right? So we're talking about the interest for the stock, and we're adding that to the interest of the savings account, okay? And we want that to be equal to the total interest, which is going to be at like 8%. We'll talk about that in a second, okay? So we want to return 8% of what? Our interest is 8% of what? That I want to get back.
8%.
8% of what? Your principal. What was our principal? Yeah, 9,000. And we're only putting in for 1 year per year. So we're only putting in for 1 year. So really our time is 1, right? Okay, so let's go ahead and talk about our total interest for right now. Total interest, we want 8% to be returned. 8%, 0.08. Times our principal, which is 9,000. Times our time, which is just 1, right? We're only putting it in for 1 year. So we really don't have to put that 1 in there. But we have principal rate time. Or really this is rate principal time. Okay? Doesn't matter what order you multiply them in. So I want 8% to come back out, right? Okay? Now, we don't know how much we're devoting to each one, right?
Yeah.
So let's say we put X amount in stock, right? X amount goes into stock, right? What is my, that's my principal for stock. What's my rate for stock? What's my rate for stock? 0.12, 12%, 0.12, okay? Times X is going to be my the amount that I'm putting in, because I don't know how much I'm putting in. And what's the time? 1 year again, so I can just do that, right? Okay? And then savings is the same thing. Rate times principal times time, or principal rate time. Rate, what's the rate for savings? 0.06. Time is 1. Now, I was putting X number of dollars into stock. How much then am I putting into savings? If I put X number into stock, how much am I putting into savings? What? No?
Why?
Now, we can do better than Y. We could put it as Y because it's not going to be the same maybe, right? It might be the same number, like 4,500 and 4,500 in both, right? But I don't know that they're the same. So we can call them X and Y, but I can do one better than X and Y, right? Let's say I put $1,000 in here. How much am I going to put in here? 8. So how did we find what this one is? No? What if I put $2,000 in here? What's going in here?
Cool. Oh wait, no.
How much do I have total to put in each, right?
So then it will be
I have 9,000 to put in each one of these. So if I put 1,000 here, 9,000 minus X. Does that make sense? If I put 1,000 in here, 9,000 minus that 1,000 is going to go here.
How do you know to put it in savings?
We don't know how much is going in each one, so that's why we labeled as a variable, right? How do you know which one goes in which? It doesn't matter. So I could have labeled, so this is what Liddell is asking. We could have put X here and 9,000 minus X here. It doesn't matter, right? Okay? It won't end up mattering. Good question, Liddell. So you can start with X being here and 9,000 minus X here doesn't matter. Okay? So this guy, do you understand why he has to be 9,000 minus X? Okay? That just tells us how much we are able to devote to each category, right? So if 4,000 is put here, 5,000 has to go here because 9,000 minus 4,000 is 5, right? Okay, so that's how we do that. Now we have our equation set up and we just solve. Okay, so let's look at this piece right here. 0.12 times x times 1 is just 0.12x plus, okay? Now, I'm going to get rid of this 1 because the 1 doesn't mean anything, but 0.06 times 9,000 minus x. What do I have to do there? Distribute the 0.06. So what is 0.06 times 9,000? 540, okay? And then 0.06 times negative x. Negative 0.06x, yeah? Okay, equals. And I can multiply those together. What's that? 720. 720, yes? We can combine things. What do you want to combine, Liddell? 12x minus 0.06x. What's that make? 0.12, not 12. 0.06x plus 540 equals 720 now, right? Okay, and then what? Minus 540, okay? 0.06x equals 180, you said? And then? Divide by 0.06, divide by 0.06. X is 3,000. X is 3,000. So what does the 3,000 tell me? What does that tell me? 3,000 in which one?
The principal and stock.
X was in stock. So 3,000 is going into stock. That's where we put our X, right? Okay. So then what is going in savings? 6,000. Does that make sense? Because 9,000 minus X is what's going into savings, yes?
Yeah.
Yeah. Okay. So we really just plug that back in our brains, right? Okay. Now, if we would have gotten, or if we would have done what Liddell said, and instead of putting the X in stock, instead of putting the X here and putting the X in savings, and then putting 900 minus X here, what would we have gotten as an answer?
Or 6,000.
We would have gotten 6,000 to start with, and then 3,000 would have been our second answer, but it still would have been 6,000 savings, 3,000 stock. Does that make sense? Okay. Now, if they just give you one piece of it, I equals PRT, it's really easy. But this was like 3 I equals PRTs, right? Going all together into one equation. Okay? Just draw it out. Just look at the individual pieces. Okay? See what two things are going together to make your overall. And then I equals PRT, I equals PRT, I equals PRT for each of the 3 pieces. Yes? Okay? Now, simplifying that was super nice because we didn't even have to factor or do anything. We just solved for X. That was really cool. Okay. Now,
So cool.
Brooklyn's in physics. Anybody else? Wynn and Holly. Even like applied science people, whatever. Nobody's in applied science. Okay. Distance equals rate times time. Right? Distance equals rate times time. If I'm going 60 miles per hour for 2 hours, how far have I gone? 120 miles, right? Distance equals rate times time, right? If I go 60 miles an hour for 2 hours, I've gone 120 miles. Distance equals rate times time. That's how you calculate it, okay? So this is another equation to put in your tool belt, yes? Okay, I equals PRT, and then this one, distance equals rate times time, is another one that you will maybe use, okay? So, now, again, if they do distance equals rate times time, just one thing, it will be really easy to do this problem, but I'm guessing they're not, right? They're going to talk about 2 planes that are flying together or blah, 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 whatever, right? Oh, man. A pilot wants to make an 840-mile round trip from Cleveland to Peoria. Okay, now hold on just a second. Let's talk about an 840-mile round trip. What's one way?
I don't know, half of that.
Wait,
Divide by 2.
It's 420.
Okay, so I'm just mapping this out. Right? What did he just say?
You laughed.
You
at me.
laughed.
420.
You're like,
And you went,
420. Sure, whatever. Okay, I don't know what I did. So, 420 plus 420 gives me the whole round trip, right? Now, here's the deal. The distances will be the same. The distance going will be the same as the distance coming back. But will the speeds necessarily have to be the same? Right? Going there, I could go faster, and coming back, I could go slower. Right? How about the time going there and coming back?
Well, no, that could fluctuate.
That could fluctuate too, right?
Wow.
Going there, coming back. Now, not even considering time zones, okay? When I traveled to, listen, when I traveled to England, it's been like it's been like 8 years ago now. I traveled over to England for 2 weeks and student taught in January for like J term for Hastings College, right? Okay. So I went to that for 2 weeks, yeah. And so it was interesting because going over there was 9 hours, not including like time exchange or anything. 9 hours going over there, coming back was 7. How did that work out? We weren't going any faster.
The wind.
The wind, we had a wind behind us pushing us coming back, right? Does that make sense? What?
No, I was going.
There you go. All right, just wait.
Miguel has the story. Miguel has the story.
What?
And you say it's Payne's fault, he's
When
done
we went
nothing.
when I went from Georgia to Spain, it was 7 hours, and then from Paris to Minneapolis was supposed to be 7 hours or 9 hours, and it was 11 hours.
Oh, you had to go around it?
Yeah,
Yeah.
and I-
See?
and I had 4
See,
minutes
that
to go.
happens. That happens.
How long did it take us to get back from Peru? Like 2 days. So
Yeah, I did.
So
Literally
if
2
you
days.
We
did not
7-hour
sleep for 2
wait in
days.
Atlanta.
Okay. Stay in. Knock it off. All right, so 420, 420, 840. This is talking about distance, right? Distance. Okay, now, they're going to give us some time. So, Cleveland to Peoria and back was a 5-hour flying time. 5-hour flying time. Now, does it necessarily mean that it was 2.5 hours going and 2.5 hours coming back? No, we just talked about that, right? Going there, you could go faster, and coming back, you could go slower, or vice versa. So, there will be a headwind of 30 miles per hour going to Peoria, and it is estimated that there will be a 40 miles per hour tailwind returning, okay? So what does headwind mean?
It's going on your head.
It's like coming into you. So, going there, we're going to go slower by 30 miles per hour, and coming back, we're going to go faster by 40 miles per hour. Does that make sense? 30 miles per hour slower because it's coming at me. The wind is coming at me, right? And coming coming back, it's going to push me 40 miles an hour faster. Okay. All right. At what constant engine speed should the plane be flown? Okay. So we're talking about distance equals rate times time. Yeah. Distance equals rate times time. Okay. So we need a.
Velocity equals distance divided by time.
Yeah, you're right. Rate times time plus rate times time equals rate times time. Okay? Rate times time, rate times time, rate times time.
What the heck?
What?
RT plus RT.
Because going there, coming back
Oh, it's different.
is different, right? Okay, so this is kind of like the stock and investment or stock and savings question. Going there, coming back equals the total. So going, coming, total. Going, coming, total. Going, coming, total. Yes? Okay. Now, what do we know? What do we know for sure?
We know that
The
the
miles.
420 is 420.
420, 420.
I
Okay?
guess it has nothing to do with it, but.
Okay? What do we know?
Okay, so we know the distance, and we know
What?
how fast they're going.
We know
Okay.
10 miles per hour, 5
5
hours.
hours.
Okay? 5-hour flight time total. Where does that go?
Oh my gosh, that goes under total.
Under total time. This is 5. That's a 5.
Oh my god.
Whoa, why
Okay.
did you just write over that?
5 is total time. 5 is total time. Okay? Now, let's think about this. What rate would we have to be going? Hold on. What rate would we have to be going if we can do this in 5 hours at 840 miles in 5 hours?
Divided.
Divide it. So our constant rate needs to basically average out
168.
to be 168. So I'm going to put in here 168 for my rate. Yeah? Okay, that's going to be my rate. Let's do that because then we'll end up having this whole thing be 840 when we multiply it out, right?
You get 168.
Whoa.
840 divided by 5.
Yeah, 840 divided by 5. So averaged out, our rate should be 168. which is not going very fast. Our plane's gonna fall out of the sky.
Yes.
Which
That's
is
not very fast.
Hey,
How'd you figure that one out?
Wait, what? Does Amber have that?
Why did we have to do that?
I feel like all people.
Like, why did we have to do
That
that?
is so 2000.
Because we're talking about math.
Hey,
and
my-
All right,
so
Going, coming. Let's talk about the 40 and the 30. The rate when we are going, we're going slower. So whatever rate that we're going, we have to subtract 30 from it because that's how fast we're actually going to be going, okay? So rate minus 30. So if we are going 200 miles an hour, it's going to feel like we're only going 170. Does that make sense? Because there's 30 against us, okay? It's going to feel like we're only going 170. So there's that. Plus, what's this one going to look like?
Plus 40.
R plus 40, because now we're going faster. So if we're going 200 miles an hour, it's going to feel like we're going 240 times the time, right? Equals.
This is
Uh,
so amazing.
I'm just going to do 168 times 5.
That's literally 840. Why don't we just write 840?
We can write 840 if you want to.
What?
We're going to do it here in a minute.
Yeah.
Okay? So rate times time, rate times time, rate times time. Now, here's the problem with the way that we have this going right now. We have two variables still. We have rate and we have time.
Well, we got the.
5 hours flying.
What?
What?
So what can we do? What can we do to plug in things or something to get rid of and only have one variable? Rate, time, any suggestions?
No, I don't know.
Use the 5 hours.
What?
Fully use the 5
Have we fully used the 5 hours? We can't do 2.5 for t, right? 2.5 and 2.5 for t because we don't necessarily know that one is going faster than the other.
Oh, we'll do 3 and 2.
How about
T.
5 divided
T.
by 2? 5
T or
minus
T
3.
minus
5 minus
I did this.
Okay. What about the 8?
What?
Fully use distance?
Have we fully used distance? I don't know.
Here, right there.
The 840? Like we haven't done anything with the 420 yet.
Oh!
I just think
This
I'm
would be
being
rate times time.
420 and 420.
Yeah? What about it?
You're gonna minus that by 30.
What you're just telling us the answer.
I
Just use
don't
this.
know.
That's just this.
Why are we doing this?
I'm brainstorming. Let's figure out what we're gonna do
No,
with
you
it.
know the answer. You're just waiting for
I don't know
Is this
the
one of those
answer.
things where you have to
They probably said it differently than I did. I don't know what the answer is.
Why would you say that?
I'm not good at math, so.
Does this make sense? I'm stuck now. I'm asking you guys for help.
You
don't
don't even know
it's
it's
what.
what.
Do I need to FaceTime
Amber?
No.
Shall I go get this?
Let's ask Mr. Arms.
Yeah, how's the head?
Yeah, give me a start.
Why would we ask Mr. Arms, guys? What would he actually tell us?
He is
No,
smart.
he's actually. Like, he helped me with one
You guys don't understand how easy it was to look
Why don't we subtract some things over? Is that a thing?
No, because
Those
you
also
have
easier
variables
math.
and you can't get rid of
Okay,
the
okay, okay.
You do TR.
I'll buy what they're doing.
Mr. Arms divide it? I mean,
at.
add
No.
it.
You actually put it
Add
in
it or
part-
subtract it?
Let's look at this. Let's do this, okay? So rather than talking about these in terms of distance, here's what they thought to do. So, distance equals rate times time, right? Okay, distance equals rate times time. Each one of these, distance equals rate times time, and distance equals rate times time. Okay, so you have 3 of these, right? Okay, so let's think about it in terms of this. I don't know that time is the same going and coming back. In fact, I know it's not, right? But I do know that the 2 times add up to be 5. So this guy is a time, this guy is a time, this guy is a time, right? Okay? So the time of this guy plus the time of this guy equals the time total. And the time total is 5, right? Okay, so let's think about it this way. If I know that distance equals rate times time, how can I solve for time?
Distance
This would be a lot easier if we just make our triangle like in Mr. Moose class.
Sure, do it. Distance divided by rate is equal to time, right? Distance divided by rate equals time. So if I want to add the two times together and have it equal to 5, let's do distance divided by rate on each one. Okay? So we do know that this distance is 420. It has to be 420, the same going and coming back.
420 divided by r minus 30.
There you go. Now we've got it figured out.
Wow.
And 420 divided by r plus 40 equals 5. Yeah? Okay, so rather than having the distance plus the distance equals distance, we did rate or time plus time equals time, right? And then solve for each one of those, whatever time was. Distance divided by rate. Okay, that's kind of cool. Now where do we go from here? Now we only have one variable, right? We only have one variable. Okay. Suppose I don't want to simplify this at all any further. Can I plug it into my calculator and have the calculator do it for me?
I don't know.
Yeah, because Mr. Moose shows us how to solve any equation for any.
What?
So,
So 420 over x minus 30, because we'll have to switch it to x's.
How?
you know math? No, Holly, it's our secret.
No,
Shut up.
There's
Y'all
that.
need to take physics.
That's dumb.
There you go. There's that. Yeah? Yeah? So I move the 5 to the other side. So you do it over your way, and then you can show me later, all right? So let's type this guy in. I'm going to move him over.
51.
On. Nope. Y equals.
I don't even have a graphing calculator. I have a Chromebook.
That's all I have, kid. I'm doing it on my computer, too. Clear. All right, so.
Graphing calculator you did have up there.
Cade took it.
Oh, whoa.
Oh my gosh.
420 divided by. Now, you need to, when you type this in, put it in parentheses. Parentheses. X minus 30. Plus 420 divided by x plus 50. Or x plus 40.
Just do it.
X. Yeah. That's the only one that the calculator recognizes. So minus 5. Everything's all to one side. I set it equal to 0.
I can't see your thing.
Can't see my thing. I can't make it exposure any up.
You do 420 divided by.
Parentheses x minus 30. 420 divided by parentheses
Negative
x
3.
plus 30.
Oh.
Wait, you get negative 3 point blah, blah, blah.
I don't know. You talking about the answer?
I'm
Yeah.
trying.
I don't know.
I think I forgot the extra.
That sounds about right. Negative though?
Did you do that for mine?
Okay, minus 5. There you go. Good.
I got negative 3 point.
Take that guy. Let's graph him.
29.
Graph him. Graph.
It
Oh,
It works.
there he is. Does he cross just once?
Whoa.
Why does mine not?
Yep.
I don't know.
What the heck?
Okay. That's what
Mine
mine
does
looks
not
like.
look like that.
Not here.
All right, let me look at your
You're
equation.
graphing it all.
You're zoomed in. Zoom out. Zoom out. Zoom out.
Why do I graph this? I know, but look.
I did that too. And then I got that. How much do you have? 2.
Um,
No.
I don't think I did it right.
No, we're gonna have to say no.
You know me. Maybe I typed
If you look at my graph,
Hey, commentaries is right. What's your
Oh my lordy.
Jesus, help me.
Y equals 420 divided by x minus 30 plus 420 x plus 40 minus 5.
Do you have enough?
that doesn't even make no sense.
Up, graph. Ah, there we go.
Negative
Who got
12.
this?
Wow, that's what I got.
That's what I got the first
time. What did you do?
I don't know.
Totally look at mine.
I typed it in wrong.
I'll
Zoom.
draft it.
Out. Zoom out. Enter. Enter. There he is. There he is. There he is.
Holly, look at
Hey.
me.
So he's only crossing in one spot. Or is he? Or is he? If you zoom out again. Did you get the same thing I got?
Yeah.
Ah, because you used a negative 30 instead of minus 30.
Oh,
It's a
that's what I
negative
did.
10. Wait.
There he is. There he is. There he is. Okay, zoom out again. There you go. You should look like this. So you will get the listen. You will get the same graph as I got to start with.
Oh, I was right.
But you're right. If you put in accidentally negative 30 instead of minus 30, don't use this negative symbol. It's minus. Okay.
How can you have a negative?
So this is what he should look like. How can you have a negative? Listen. How can you have a negative? You can't.
Because
So,
minus
no
30 equals
solution.
40.
I'm only looking at. I'm not this guy. I'm not looking where he crosses. I'm looking where he crosses. Right? Does he cross?
No.
I'm pretty sure he does.
It does not look like.
Yes, he does. I'm pretty sure he does. Okay, so let's go over here and let's zoom. I'm gonna zoom in. Zoom in. Enter. Go all the way over. Zoom in. Enter. He's gonna cross, but not right there. He's gonna cross all the way over. Zoom in. I gotta go all the way over, all the way over, all the way over. Zoom in.
This is
How am I supposed to have this?
With your finger.
Morgan, you forgot your minus 5. She forgot her minus 5. It says minus 5.
Yeah, mine's not going over. Window. Let's go. X max. Let's go 150.
Wait, she forgot her minus 5. That's not right.
Just wait. 150. Let's go 250. Let's see where he crosses. Graph. There he's going down below. You see him right there? So I'm just guessing a new window. Guessing a new window, and I'm zooming again. Zoom in. Let's go over here.
I might.
I'm gonna go right there. Oh, come on, 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 come on. Yes, there we go, right there.
You're gonna ruin the trip.
Sorry. Enter.
I just got an even longer.
There he is, right there. Right there.
I forgot the minus 5. With your window.
I keep zooming in. There he is, right there.
What the heck? Look at Morgan's window. This is like she can see it.
I see it, like 170 miles per hour.
Negative 1.
You see that?
Didn't you guys get like 12?
170 miles per hour?
I still got an even longer line.
Or what?
I got negative 12.
Go out to 170.
That's wrong.
Negatives don't work. You know that.
fine. Well then, but I think it will
Take
work
the window.
if we just
I got it.
different X.
I'm doing
What if
it.
we had a different X? It'd be
Give up.
right.
I'm not
You
going
just
to
have to
college.
enter in a different
And what's
I'm
your
gonna go. I'm not taking a year off. I'm just gonna freaking.
How am I gonna know how to buy this?
Oh, man. Just zoom out.
Yeah, I'm gonna find myself working at
Oh,
McDonald's.
no, it's stuff for you.
What happened?
I didn't tell my parents I took a gap year.
Right.
That's what I'm doing.
Crossing somewhere over there. Let's see where he's at.
Where do you want to go?
Somewhere that makes me football.
I love how we did that. Like,
Oh. Yeah, actually, that's one reason, and another
So
reason.
what's this actually
College.
supposed to
Yeah, valid. What?
Is this supposed to look like
Oh,
this?
good.
Let's go out of state.
Yeah.
It is.
I go
Wait.
to.
There is that right crosses. I'm gonna say 170. Yes, he's crossing exactly 170. Yes. Okay. 170 is where I think he crosses. If you look at it, it is 170 indeed. Yes? Yes?
So where does this go?
Okay, so what does that mean?
X equals 170.
What does that mean?
It means that is, what is it? It's R. Is that what we decided it is? R?
R? Yes? What does R stand for?
Right.
R stands for how fast I'm going. So I'm going 170 miles per hour. Okay, now let's go through and let's solve this just real quick algebraically because it's not terrible hard. 170. If you keep looking on your graph and zooming in and zooming in and zooming in, it is 170 exactly. Let's see algebraically. Okay, I'll go through this real fast. If this confuses you, don't write this down, but I'm going to go through algebraically how this is solved, okay? So we had 420 over x minus 30, right? Plus 420 over x plus 40. Yes? Equals 5. Okay, so let's do this. Let's get a common denominator on this side. Let's get a common denominator on this side. Alright? Well, actually, let's get a common denominator all the way through. What are you going to have your denominator be? No. Can't be that. This is like a quantity right here. X minus 30 and x plus 40. What can my common denominator be if I'm going to combine stuff?
Don't you just take 170 minus 30 and 170?
No, well, no. I'm trying to get 170 using algebra. Well, yeah.
That's only 70.
Okay? Do you see what I'm doing?
Start over.
Okay? Alright, so don't write this down, but watch. I'm going to see if I can get 170 by doing the algebra, okay? Doing algebra. So x plus 40, x minus 30, x plus 40, x minus 30. That's my common denominator, right? Okay? So I need, up here, let's multiply those together. X plus 40, x minus 30, yeah? Okay, so on the top I have 420x plus, what's 420 times 40? 16,8 with 2 zeros. Yes? Okay, now plus 420x minus 420 times 30. 12,600 equals 5. Yeah? Okay? So I have them all under the same denominator. Okay? Just watch this. Just watch this, okay? Found my common denominator. They're all under one roof. Yes? Yes? Okay? Let's simplify the top part real quick. 420 and 420 makes 840, right? So this guy's 840x. And 16,800 and 12,600, if I subtract, that's 4,200. 4,200, yeah? Okay, and then what? What's the bottom? What's x plus 40 times x minus 30?
X squared minus. No, that's wrong. Don't listen to me.
Yeah?
Yeah?
That's what the bottom is, right? The two outside multiplied together. These two added together make 10. Yeah? Okay? Now, I have this.
30 plus 40.
I have this over this.
Oh, wait, yeah.
It's negative 30. I have this over this, and I want to get just 5.
I was like,
No, because this is all one piece at the bottom.
Okay.
So right now we have 8.
Multiply that times 5.
Yeah. Over x squared plus 10x minus 1,200 equals 5. Okay? There's that. Okay? Now I just rewrote it. Now what?
Now you multiply all that times 5. So 5.
Okay, so multiply by the x squared plus 10x minus 1,200 times x squared plus 10x minus 1,200. 840x plus 4,200 equals yeah, 6,000. Yes? Yes? Okay, now we're getting closer.
Now we get to take out 5.
Okay, let's get it all to one side first. Right? Take this guy and move it to the other side. Take this guy and move to the other side. So I have 0 over here. Equals 5x squared. 50x minus 840.
I ran out of room.
Minus 10,200. Okay, then what?
Now you can factor it out.
0 equals x squared minus 1, 5, 8, x minus 2, 4, 0.
Oh my god.
No,
Yeah.
no.
No, it is.
2, 0, 4, 0.
Yeah, 2, 0,
20, 40. Okay, now, can you break that thing down?
yeah.
You betcha. You can. Haha. Or you can type it into your calculator. But those of you who are complaining, listen to this. Those of you who are complaining about graphing it on the calculator because it's so hard when you can just freaking zoom in and out, okay? This is your alternative. Look at all that disgusting crap.
Oh my god.
Yeah. Just zoom in and out on your calculator. You can
We're
do
still
it.
not done with those.
Okay. We're still not done with
We're doing less
those.
problems
But I
than
am
we
going to
did
give you the
yesterday.
homework.
No.
Oh, no.
I don't know whose fault it is anymore for notes, but like.